In this section, we are going to look at the container security parameters and Keystone principles that you have to keep in mind to protect yourself when you are using Docker. Now that we have run the maps from the previous container attack section, in this section we are going to look at the ways to protect ourselves from such attacks. Okay, with that, let us look at the learning objectives of this section. So first, we are going to look at the important parameters to keep in mind for container security. Then we are going to look at container security engineering so that our implementations of Docker containers are secure. Then we are going to look at approaches to build secure containers in order to reduce overall attack surface when we are implementing Docker containers. And finally, we are also going to look at some of the runtime security protection so we can use when we are running Docker containers. So when it comes to container security, there are 4 key concepts you have to keep in mind. Your containers at the end of the day are still running on the host machines, right? So the first thing you have to do is ensure that the host machine where you are running your Docker containers are secure. You can start off by creating a separate partition for containers, and you also have to make sure that the container host machine has been hardened. Also, keep your Docker up to date so they're releasing patches especially for security quite often. And allow only the trusted users to control the Docker daemon, because in our previous container breakout lab, we saw what can potentially happen when a non-root user has access to Docker. And finally, let us audit the Docker daemon. So your Docker files, all the other directories which are important. Then you can start looking into daemon security mechanisms, so where you can restrict some of the traffics between the containers. Also, please do not use insecure registries, as an attacker can trojanize Docker images and push this particular trojanized image to Docker registry. And finally, try and configure TLS authentication for Docker daemon. So moving on, here are some of the Keystone principles we have to keep in mind when we are using Dockers. So the first one, your container is not a full-fledged operating system. Try not to run multiple services inside a Docker container, okay? So a container should run only one particular service. And if you have to run multiple services, you can use multiple containers. Avoid using Ubuntu, Debian, or any other heavyweight distros. They basically come up with a lot of excess code and a lot of libraries that you might possibly not be using at all. So this ends up, increasing our overall attack surface by like 10 times. Next, you have to use the trusted base images for containers. So the last thing you want to do is issue a trojanized image when you are building your application containers. So you have to ensure that the image that you are using is coming from a verified source. And the next very important thing is, do not store secrets in the Docker file. So we saw how easy it is to run the Docker history command or use tools, thereby analyze multiple Docker layers, and if you have any sensitive informations as part of your Docker file, anybody who has access to your Docker image will also have access to all of these secrets that has been used in the Docker file, okay? And finally, one more important thing is, do not run the container as the root user or with the user ID that is equal to 0. So these are the very important principles when you're using Docker. So we did understand that the container file system are built from our existing operating system distros, and these containers run a lot of unnecessary code. So unnecessary code often means insecure code, as these distros have software that's vulnerable to a host of issues. Okay, so building minimum containers reduces the attack surface and also reduces the unnecessary code in our container. So in the upcoming labs, we will be understanding about how the distroless lab work, the Docker Slim lab works, and all of that. So why wait? Let us dive there. See you.